So today we're doing tangent. We're going to start by finding the tangent at each angle. You remember we did this with sine, and we did this with cosine. We're now doing it with tangent. What is tangent?
Whatever else is it.
It is opposite over adjacent if we're going to draw a picture for every single angle, which you can. It takes about 4 times as long maybe. Or if you just know the stuff, save yourself a lot of time. So we'll start at the first angle, 0. And for the quadrantals, remember we have to use the ordered pair. What is the ordered pair at this point?
1, 0.
So for tangent, we do y over x. And we get 0. Pi over 6.
Actually, I made a mistake.
Pi over 6 is a what kind of degrees angle? That's a 30. So what's the tangent at 30? Square 3 over 3. Radical 3 over 3. Pi over 4 is what angle? What's the tangent? 1. Pi over 3 is what angle? 60. And the tangent of 60 is square root of 3. And we go to pi over 2, and that's another quadrantal. So the quadrantal, I need to write the ordered pair. What is my ordered pair?
0, 1.
0, 1. And the tangent is y over x. So we do 1 over 0, undefined. UNDF, if you want to abbreviate. And then we go to the next quadrant. And what happens to tangent in the second quadrant? It's negative. It's when we do the all students take calculus, all students, the only sign is positive here. So tangent is negative. So we're going to use these same values. This one is another 60 degree reference angle. Degree reference angle, so it's going to be the same value as square root of 3, but it's negative. This one's going to be the same as that one, only it's negative. This one's going to be the same, only it's negative. And then we get to the quadrantal, and we have to use the ordered pair, negative 1, 0. What is tangent y over x? 0. And then we go to 7 pi over 6. And in this quadrant, tangent is what?
Positive.
Positive. Because we do all students take, TTT, tangent, positive. This one is the same as a 30 degree, only it's positive. So square root of 3 over 3. Five pi over 4 is the 45 degree, only it's positive, so 1. 4 pi over 3 is the 60, but it's positive, bless you. So square root of 3. And then at 3 pi over 4, we're at the quadrantal again. We got to write the ordered pair. What ordered pair is that? That is 0, negative 1. We do y over x, and we get undefined. What happens to tangent in the fourth quadrant? It's negative. So this 5 pi over 3 is a 60 degree reference angle, but it is the negative. So we negative square root 3, then negative 1, then negative square root 3 over 3. And then we can keep going around and around if we want, because it repeats. Now there's something special about tangent that cosine and sine are different. We start at 0 and we go all the way around. We start at 0 and we go all the way around. If you look at these values, square root of 3, 1, square root of 3, undefined, negative square root of 3, negative 1, negative square root 3 over 3, 0. Then from there, they completely repeat exactly in the same order that they did the first time. These repeat again in that order. Do you see they're exactly the same order at the bottom? So when we talk about things having a period where they repeat, tangent's period is half of the circle. Because here, tangent repeats twice. So tangent's period is only half. What would tangent's period normally be, the parent function?
Pi.
So that's different than cosine and sine. The period is always pi unless we have some sort of stretch. The period is always pi. The key points that we use are also different. For sine and cosine, we use the entire circle for the key points. For tangent, we're only going to use half the circle, but it's not the half that I highlighted. So I'm going to show you the key points for tangent. We're going to make the middle key point 0, okay? And at 0, tangent is 0. So that's an easy one, 0, 0. We are going to use pi over 4 because that one has a value of 1, and that's an easy value to graph. So my next one down is going to be pi over 4, which is 1. And then we're going to use pi over 2, which is undefined. Now, the other values that we use for tangent is we're going to go negative. Instead of going all the way around the circle, we're doing some up and some down from 0. So the next one we're going to do is negative pi over 4, which is negative 1, and then we're going to do negative pi over 2, which is undefined. So tangent's just kind of different than the other ones. We can really graph every single ordered pair if we want, but just to graph it with some key points and connect to make it easier, we're going to use the ones that have easy values. And we're using the ones that go in between two undefineds. We're also using positives and negatives so that when we graph it, we're graphing right around the y-axis. That's why we're using positives and negatives instead of positives and more positives. We're doing it so it's centered around the y-axis. Okay, I am going to use 2 colors when I graph this, just in case you're a color person and you want to. I'm going to do my first colors with the ordered pairs. So the ordered pair 0, 0 is one of them. There's the ordered pair pi over 4, 1. Pi over 4, 1. There's also negative pi over 4, negative 1. So to graph, when it says undefined, that means that the graph doesn't exist there. And we have done graphs that have values undefined before. No, that's imaginary. But we have done where values are undefined. Undefined means you can't divide by 0, or dividing by 0 is undefined. We've done graphs when we did the rational graphs. And when it's undefined, you just make it an asymptote, a vertical asymptote. So undefined, we have a vertical asymptote. So at pi over 2, I have a vertical asymptote. This is where my other color is. And at negative pi over 2, we have a vertical asymptote. So we go to connect these. These points do connect to each other. They are curvy. So let me show you what the curves look like if you've never seen tangent before. But when they go closer to the asymptote, what happens at the asymptote? It just gets closer and closer to it. Does it pass through it? No. It doesn't just stop. It does go on forever, but it gets so close to it you can't really tell. So we're going to curve this one and just get closer to the asymptote the other way. I'm going to curve it the other way. And just get closer to the asymptote. If we found more ordered pairs and we plotted them, this is what tangent would look like. So this is one cycle. We need to repeat the cycle. The cycle is pi long, so we need to go the same distance apart with those asymptotes. The same distance apart with those asymptotes. And then we need to repeat the pattern inside those asymptotes. That is the tangent graph. When you have it graphed, go to the next page. When you have it graphed, you go to the next page, write down your key points in the table in the next page. So tangent goes from negative pi over 2 to positive pi over 2. There's 0 in the middle. And then from there we half the values and we put pi over 4 and negative pi over 4s in there. People make silly mistakes and put them in the wrong order often. I see it because you try to put them in numerical order and you're thinking 4 comes first, but it doesn't. Pi over 4 is in between pi over 2 and 0. It's a 4, not 4. Do you understand what I'm saying? People mess up these values by accident. So we've got to know the order of fractions. Okay, then tangent starts with the undefined and ends with the undefined. Right in the middle is 0. Which number goes here? Negative 1 and then positive 1. And I showed you how we got those values to begin with. We had the unit circle and we found the values. So if you ever get stuck and you're not sure if it's negative 1 first or positive 1 first, you could always draw the picture and say, what is tangent at negative pi over 4? Well, that's got to be a negative number in the fourth quadrant. If you could go through that process if you need to create it again. All right, what are we doing? We have to describe the transformation and graph it. So what does plus 2 do?
Translate up to.
Translate up to. How do we know it's not left? How do you know that? It's right next to you. So it looks like it's with the x, but there's no parentheses. That's how you know it's with the x, is if there's parentheses. So there's not, so it's not with the x. So we're going to do up to. So I have an undefined line. Can anybody give me an undefined asymptote? Okay, give me your asymptote. Now what I want you to do with this asymptote is I want you to translate it up to. Still the asymptote. So it's still undefined. Yay. What would make this asymptote move? Left or right? Not. All right, and then, is it? And then we have to add 2 to the value, so we can actually add 2. Let me graph it. I like to do my asymptotes in a different color. It's a little easier to see them, but that's just me. So my undefined is still at negative pi over 2 and pi over 2. I gave you the different graph for this one, the ones that are more like the homework graphs. pi over 4, you have to know, is right in the middle. Wait. Once you have those graphs, then you can just repeat the process.
Why is it that these asymptotes are closer together, but on the other?
Because of the scale. Look at the scale of the first one. Oh yeah, I like gave you a different graph for the first one. Just because it was the first one, I wanted it to be more zoomed in, I guess. But for these are the ones that are more like the homework. Now we could have asymptotes that end up being closer together. What would make our asymptotes go closer together? Horizontal shrink.
So it's 6x. Not that much,
Well, it would be like tangent
but tangent
6 something, or some number in front of you. What is our period for this? And again, if you're unsure of the period is horizontally the distance for one cycle, and one cycle is in between the asymptotes. So horizontally, that is a distance of pi. Questions? Next one. Oh, good question. Amplitude we're not going to do for the tangent.
Because you can't define the amplitude of this stuff.
Well, you could go from the center point to those first key points, but it's not really the same thing that it was with sine and cosine. It was the top. It was the maximum and the minimum value, right? The tangent goes on first. It's a little weird. So we're not going to say amplitude for. And in your homework, I did ask you to write the amplitude and the period for each, but then I included tangent. You just won't put the amplitude for tangent. Okay. All right, so this one, what is our transformation?
Translate left negative pi over 2. Or
I think you
translate
gave me
left
a
pi over
little.
2.
You gave me a little double
Shut up.
negative in there. Translate left pi over 2. Yes. So we will subtract pi over 2 to the x's.
Whoops.
So remember, the x value, start at negative pi over 2, go to positive pi over 2. 0 in the middle, then we do our pi over 4s in the middle of those. Y values start at undefined and end at undefined. 0 in the middle, then negative 1, then positive 1. So we're going to subtract pi over 2 from negative pi over 2. Okay. That was a big one. We're going to subtract negative pi over 2 minus pi over 2. What does that give me? Negative 2 pi over 2, which is negative 5. You don't have to write the work if you could figure it out yourself, that if I start at negative pi over 2 and I go negative pi over 2 more, it's at negative pi. You could look at the picture and see that too. Start at negative pi over 2 and then go pi over 2 more, it's negative pi. You don't have to write the work. Negative pi over 4, subtract pi over 2. I would need common denominator. I'm going to multiply the top and the bottom by 2. I'm gonna get negative 3 pi over 4. 0 minus pi over 2 is negative pi over 2. Pi over 4 minus pi over 2. Common denominator, multiply by 2. And I get negative pi over 4. And then pi over 2 minus pi over 2 is 0. And I like to start with my asymptotes first. What are my asymptotes? Negative pi and 0. And then my 0 point is at negative pi over 2. And then we have our point in the middle. The nice thing is that these are always evenly spaced. They picked values that are evenly spaced. We can graph them very easily. They're evenly spaced. Did you figure out your period for this one?
It's the same.
What would make the period change? A horizontal stretch or horizontal shrink would make the period change. We haven't had that yet. So the period is just going to be pi unless we have one of those. All right, the next two are you try. But of course I'll go over them. But you take a moment and try them. Before you draw those first asymptotes. Okay, so I've given you one that you really do kind of have to think about adding fractions possibly maybe. So we have to start at negative pi over 2 and add pi over 4. That means I'm going to have to multiply this negative pi over 2 by 2 over 2 to give a common denominator of 4. So I have negative pi over 2 plus pi over 4. It's going to give me negative pi over 4. My next one, negative pi over 4 plus pi over 4 is 0. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. And then pi over 2 plus pi over 4. That's like half plus another quarter, 75 cents. No? I'll leave you on that one. Half a dollar plus another quarter, 75 cents. It's 3/4, 3 pi over 4. Or you can just find common denominator. I always feel like you can't do fractions until they like make it money, and then you're like, oh, I know what I'm doing with money. Okay. Grabbing it. We have an asymptote at 3 pi over 4 and an asymptote at, what's the first one, at negative pi over 4?
Yes.
Okay, so negative pi over 4 is exactly in between negative pi over 2 and 0. It's exactly in between there. 3 pi over 4 is at 3/4 of pi. Pi over 4 is at 1/4 pi, 1/4, and that is at 0. And then what is our period? How far apart are these asymptotes? Pi apart. So when you draw more, just make sure that you're going exactly the same distance every time. Awesome question.
Isn't it supposed to be 0, 1?
0, negative 1. Did you have the 1 and negative 1 switched?
Yeah.
That happens. So I'm just following my pattern. I'm putting that center dot right in the middle of those asymptotes. If you're done with this one, go ahead and work on the other one. So if it were plus 30, well, great. You can break it down. When you do assignments, and definitely when you do quizzes and tests, you should not just put like one of these and call it a day. You should be able to repeat this as far as the graph goes, with the exception of if there's going to be more than 4 on each side, then you can go ahead and just do 4 on each side. But don't take shortcuts. You want to show me that you can do 5 full cycles. Last one is a translate what? Translate where? 3 units down. That's affecting the y, minus 3. If I take an undefined and I subtract 3, nothing happens. Still undefined. So my asymptotes are at negative pi over 2 and pi over 2. Would the graph ever not go up? Yeah, would the graph ever not go from left to right up? Well, what would be reflection? I mean, what would the equation look like?
Negative.
Yeah, negative in front. Yeah. Okay, if you're finished with the notes, your assignment is those 9 questions in the packet. And the first 6 are just review over cosine and sine, and then the last 3 are tangent. If you feel like I want to practice tangent first, then do the last 3 first. If you just want to go in order, that's fine too. I gave you review over sine and cosine, and then 3 new tangents.